Okay, so this is going to be my assignment 3 video. Let's go ahead and jump right in. First thing I'm going to show is the synchronized consensus algorithm. So in one of my clients, I'm going to set the broadcast mode to non-atomic. Okay, so the first breakpoint that we see was right after the proposal was made, but before we make the call to send it to the server. So that's why the server hasn't gotten anything. Let's go ahead and take a look inside this function. Okay, so our second breakpoint is a little bit later on, but our server received the request. Now it's going to send the request to all the clients for them to vote on. So that's where we're at right now. It has sent the first request, and we have a breakpoint right here that, and one of our clients has stopped it here. So if we go here and we do, I believe F6, if we step over it, we'll see in our client that the proposal accept request was received. So now it's going to vote on it and send that back up. All my clients are going to vote true for the purpose of this demo. So now it's sent it back up, and if we go to the next breakpoint, we'll see that in our server it received this client's vote, and then it sent the information to the next client to vote on. So we're back at the same spot here, but in the next client. So if we start that, we'll see in our second client that it has received the information to vote on. So let's go and do that. Now it's going to send the notification back up. And if we keep resuming, we'll see that in our server it received the vote from the second client. So now the state of both the clients are not stable because they've accepted that they want to vote on, or that they voted on this and committed it, but they haven't heard back from the server to actually set it as the value. So because we paused the server before it does that. So if we go to one of our clients, we try to tell it to do something like 50, 0, let's see. We're going to get a message from our client saying it failed to process the command because the client is not stable, because it hasn't heard back from the server to actually save that value and start using it. So now if we come back to our server and we just resume, we'll see that it sent the notification to actually set the value to both of the clients. It did that twice. Each of our clients will see that the proposal state was set. So now both of them should be in non-atomic mode. I'm going to just run the rest of the debug statement so it's done. So now, if we go and do that same command, we'll see that our things are resynchronized and working. So that was the synchronized consensus algorithm. So now we're going to show asynchronous RPC calls done using gypsy. As you can see, I have my 3 clients set up, and they're using gypsy as their command and atomic as the broadcast mode. So let's go ahead and run a command of take 1. Okay, so our first breakpoint is in the client that we just typed the command in. Before it even broadcasts to the server, it really hasn't output anything to the console yet. So let's go ahead and step through. We get this trace line. So now if we step over this line that's going to call up to the server, we'll see that the call returns before the server is done executing the remote call. So we get some stuff. So right now, we'll see that our server application is suspended at breakpoint line 181, which is right here. So it hasn't started this for loop to send all the commands back, but our client that sent the command has already finished the remote call. So if we go ahead and just come back to this client that we sent it to, we're just going to go ahead and finish that. We're going to just resume the whole execution. So we'll see that that client is done and back to running. So it's completely finished this call before the server has sent back the callback because we have this breakpoint. So now if we look at this breakpoint in the server, we're going to go start stepping through. So we'll go through this for loop. We'll run the command in the first callback. We will see that it came back up to the top of this for loop. So it finished that call, came back up to the for loop. But one of our clients should be paused. Let's see, yep, our third client down here is suspended at the next breakpoint line 28 in its callback that's going to actually run the command. So if we go ahead and finish up this for loop, the server, okay. So we'll see that if we look here, our thread for the server is completely done. So it finished the for loop, it ran all these commands, they came back, but as we'll see, the remote call hasn't actually been made yet. So, well, in one of them it was made, I accidentally stepped through on this run command. But in our other two, we'll see that they are suspended. Our other two clients are both suspended. So if I go ahead and run those through, they'll finish executing. So that just really showed that RPC calls can be asynchronous using gypc. They don't have to wait for the remote method to finish and send the return value back. So that's pretty cool. Okay, so now we're going to run the local tests for assignment 3. Alright, they're running, and I will unslow it down when they're finished. So the test just finished running. So this one I am having a problem with. I've looked over it a few times, and I just can't seem to find the problem. It says I have a problem with the RMI process request sent line, but every time I run it, looking at the same commands that's input in the test, mine is there, so I can't really figure that one out. Looking at this one, it's the same problem, but this one's also worth 0 points. And really the big ones are these two. These are like in assignment 2 that we didn't have to implement because implementation's in the server, not the client. I didn't really implement being able to change broadcasts or metastates from the server. It always has to be done from a client because in reality, this is an application that is about clients interacting with each other. So I didn't think it was really necessary to implement the server being able to just change the metastate of all the clients. And this is what we talked about in assignment 2 with some of the details not having to be implemented. So besides that, really the only test that I'm not completely passing is this one that's worth 8 points. Okay, so now I'm moving on to the atmosphere tutorial or atmosphere demonstrations. So I was following the guide, but I could not get the VCN client to work, or VNC. So instead, I'm using the web desktop functionality at Atmosphere. So when I did that, it brought up this, which is I have my console open. I have some simulations of the server running in the background. Try not to move too much. The latency is terrible because it's but yeah, for some reason it just wouldn't let me SSH into any of my Atmosphere instances. So this is what I'm going to have to use to demonstrate this part. So these are all obviously running on the same Atmosphere instance. So I'm just going to quickly go through all the tests and then I'll put all the results in the table for the end and discuss the results. Okay, so this is going to be the second part of my Atmosphere tutorial. as I was saying, I was having trouble with VNC before, so I was able to SSH into all of my instances using the Windows Linux subsystem, which just lets me have a Linux command prompt on my Windows machine. So if you look at my path, I'm at my username and then different virtual machines. And if we come here, copy this, and we run it. So you'll see I have different IP addresses. This one's 4, 40, 12. So now I am on different instances from Atmosphere. And so we're going to run these tests now. So first I'm going to load up a server. One client, 2 clients, and my 3rd client. Okay, so the first test I'm going to run is I'm just going to run the local test. Take long, and now I'll be running the rest of the test, and I'll clip together the results in a table and talk about that and compare it to the other one. So this is the final table of results with times and seconds. As you can see, when we ran it with different virtual machines, there was a significant speed increase. Really, this is because you're running it on different machines, like we talked about in class. You're not having to do process switches and spend time doing that. So the computer can just spend all of its time and resource running the actual program. So that wraps it up for this video.